Welcome to today's paper reading. Today's paper is titled, Images are Achilles' Heel of Alignment, Exploiting Visual Vulnerabilities for Jailbreaking Multimodal Large Language Models. This paper was published on AR14 by Yifan and colleagues from Jialing School of Artificial Intelligence and School of Information at Renmin University of China. In this paper, the authors investigate the harmlessness alignment problem in multimodal large language models, MLLMs. They perform a systematic empirical analysis and find that image input presents a vulnerability in MLLM's harmlessness alignment. Motivated by this discovery, they introduce a novel jailbreak method called Hades, which conceals and amplifies the harmfulness of malicious intent within text input using carefully crafted images. Experimental results demonstrate that Hades can effectively jailbreak existing MLLMs, achieving an average attack success rate, ASR, of 90.26% for LLVA 1.5 and 71.6% for Gemini Pro Vision. The code and data for this research are available on GitHub. Multimodal large language models, MLLMs, are capable of processing both textual and visual information, demonstrating superior performance in various visual language tasks and engaging in image-related dialogues with users. However, these models face similar harmlessness challenges as their backbone large language models, LLMs, being vulnerable to both black box and white box attacks. The integration of the visual modality into MLLMs has been shown to exacerbate safety concerns, influencing model outputs and introducing additional alignment vulnerabilities. Figure 1 illustrates the impact of the visual modality on the harmlessness alignment of Gemini Pro Vision, a state-of-the-art multimodal large language model. The figure demonstrates that even blank or harmful images can influence the model's output, leading to improper responses containing harmful words. This highlights a significant vulnerability in the alignment of MLLMs, where visual inputs can act as backdoors, undermining the model's ability to maintain harmlessness in its outputs. In this section, we discuss the empirical harmlessness analyses of multimodal large language models, MLLMs. We collected a dataset of 750 harmful instructions across 5 scenarios, each paired with a harmful image. The evaluation was conducted under 4 settings: backbone, text-only, blank, and toxic. The attack success rate, ASR, was used as the metric to measure harmlessness alignment. The results indicate that images can act as alignment backdoors, more parameters during fine-tuning reduce alignment, and harmful images are more likely to elicit harmful outputs from MLLMs. Figure 2 illustrates the Hades method, which is designed to disrupt the alignment of multimodal large language models, MLLMs, by manipulating harmful textual instructions. The process involves 3 main steps. First, harmful content is removed from the text and represented in typography. Second, this typography is combined with a harmful image generated by a diffusion model, with the prompt for the image being iteratively refined by a large language model, LLM. Third, an adversarial image is appended to the top of the generated image, which is intended to elicit affirmative responses from the MLLM for harmful instructions. This method aims to exploit the vulnerabilities in the image processing capabilities of MLLMs to bypass their defenses against harmful text inputs. Table 1 presents the evaluation results of representative multimodal large language models, MLLMs, on a dataset comprising harmful instructions paired with images. The table categorizes results into scenarios like animal, financial, privacy, self-harm, and violence, and evaluates under settings including backbone, text-only, blank, and toxic. Key findings include that images can act as backdoors to MLLM alignment, more parameters tuned during cross-modal fine-tuning lead to less alignment, and there is a positive correlation between the harmfulness of image content and the harmfulness of MLLM responses. The table uses attack success rate, ASR, as the metric to assess harmlessness alignment, showing significant increases in ASR when harmful images are introduced, indicating vulnerabilities in MLLM alignment due to visual inputs. Hades is a novel method designed to automatically synthesize high-quality adversarial examples for multimodal large language models, MLLMs. The approach involves 3 main steps: hiding harmfulness from text to image, amplifying image toxicity with LLMs, and amplifying image harmfulness with gradient update. MLLMs typically consist of an LLM, an image encoder, and a projection layer. The Hades process modifies the original text instruction to a new version, crafts harmful images, and induces the model to generate harmful responses. This method aims to exploit the vulnerabilities in the image side of MLLMs, which are less aligned with human values compared to the text side. In this experiment, we evaluated several models including GPT-4v, Gemini Prov, MLLM 1.5, and MLLM 1.5L. We designed 4 evaluation settings to test the effectiveness of Hades, TYP image, plus text-to-image pointer, plus opt image, and plus ADV image. The key findings show that Hades significantly enhances the attack success rate, ASR, for both open and closed source MLLMs. GPT-4v exhibited the strongest defense capacity, while models were more vulnerable to harmful instructions in the financial, privacy, and violence categories. Figure 3 illustrates the attack success rate, ASR, of various models on Hades as the optimization steps for image generation increase. The results show a consistent improvement in ASR across all comparison models, indicating that the more optimization steps applied, the higher the ASR achieved. This trend underscores the effectiveness of the image harmfulness optimization method proposed in Hades. The models evaluated include MLLM, Gemini Prov, and GPT-4v, each demonstrating a notable increase in ASR with additional optimization steps. This finding is crucial for understanding how the optimization process enhances the attack performance, validating the efficacy of the proposed method in Hades. Figure 4 presents the evaluation results of the transferability of Hades across various MLLMs and instruction categories. It shows that Hades, when trained on one MLLM, achieves comparable attack success rates on other MLLMs, indicating its broad applicability. Notably, MLLM 1.5 and MLLM 1.5L exhibit significant mutual transferability, likely due to their shared architecture. Additionally, Hades demonstrates enhanced transferability within specific harmful categories such as self-harm, violence, and animal, as well as privacy and financial, attributed to the similar semantic contexts among instructions in these categories. Figure 5 presents the representative cases and statistics of 3 harmful response types on Gemini Prov and GPT-4v. The 3 types are optical character recognition, OCR, captioning, and instruction following. The figure illustrates the proportion of each type among all successful attack cases, showing that OCR and captioning abilities also contribute significantly to jailbreaking. This suggests that cross-modal fine-tuning may impose an inverse alignment tax, enhancing multimodal abilities while impairing harmlessness alignment. Future work should consider adding more adversarial samples during fine-tuning to improve the defense against image-based attacks while maintaining multimodal capabilities. Table 2 presents the evaluation results of various MLLMs subjected to instructions and images processed by Hades. The table highlights the attack success rate, ASR, for different models under various settings, indicating that the inclusion of Hades components significantly increases the ASR. Notably, GPT-4v exhibits the strongest defense against harmful instructions, with an ASR of 15.07%. The models generally show stronger defenses against instructions related to animal and self-harm categories, while financial, privacy, and violence categories are more likely to breach the model's safeguards. The table also shows that the addition of the text-to-image pointer and optimized images further enhances the ASR, with the full Hades version achieving the highest ASR on open-source models. The concept of harmlessness alignment involves fine-tuning large language models, LLMs, based on human preferences to ensure their responses are helpful, honest, and harmless. This process is crucial for maintaining the ethical use of these models. The robustness of these models is often evaluated through red teaming, a method used to benchmark their safety against harmful instructions. On the other hand, multimodal large language models, MLLMs, combine LLMs with vision encoders and cross-modal connectors, undergoing a 2-stage training process that aligns cross-modal representations and tunes visual instructions. Despite advancements, MLLMs are also susceptible to generating harmful content when prompted maliciously. Existing research has explored both white box and black box attacks on MLLMs, but there is a noticeable gap in the evaluation of their harmlessness, which is an area needing further attention. In this study, the authors conducted a thorough empirical analysis on the alignment of MLLMs, particularly focusing on visual vulnerabilities that can lead to jailbreak scenarios. The research highlights that images significantly contribute to these vulnerabilities through their presence, the cross-modal fine-tuning process, and their inherent harmfulness. To address this, the authors introduced Hades, a novel approach that uses carefully crafted images to hide and amplify harmful textual instructions, successfully jailbreaking both open and closed-source MLLMs. The findings underscore the need for further research into cross-modal alignment to enhance the harmlessness of MLLMs. Future work will aim to improve jailbreak strategies and develop methods to better align MLLMs, especially those that are well aligned like GPT-4v. Thank you for watching.